Okay, so good morning everyone, and today we're going to be working on Module 4, Lesson 10. Our objective today is I can compare and evaluate expressions with parentheses. But before we get started, we're going to work on some fluency like we do every single day at school. Today's fluency is going to be multiply a fraction and a whole number. So pretty much super simple, super easy. We've done stuff like this before, and the Eureka just teaches us a different way of doing it. It tells us to write our problem out, so 1/2 times 6. And so what we're going to do is we're going to combine our numerator, which is 1, and we're going to turn that 6 over 1, right? And so instead of us having to write 6 over 1 and kind of figuring it out, we're just going to say, well, 6 over 1, 2 times 1 is 2, so I'm just going to leave it as 2, and I'm just going to smooth this 6 over here. Once I've done that, I could say, okay, 1 times 6 is 6, and 2 by itself, or we keep the denominator the same, so it'd be 2. I cannot leave it like that because my numerator is bigger than my denominator. So that means I would have to do 6 divided by 2, which would give me an answer of 3. Now, I could have skipped that step of simplifying it by doing the following. I could have said, okay, 1 times 6 over 2. I could have said, well, 6 and 2, they look like they could be divided by something. So I could say, okay, 6 could be divided by 3. I'm sorry, 6 could be divided by 2 3 times, and 2 could be divided by 2 1 time. And then I could say, okay, 1 times 3 is 3, and we bring our denominator over, making it 3 altogether. So it doesn't really matter which way you do it as long as you get it done the right way. So going to the next problem. I have 6 times 1 over 3. Again, even though my whole number is in the beginning of the problem, I could still do the same thing. My 6 would be the first number in my numerator, and my 1 is already my numerator, and my denominator is 3. So then I would say 6 times 1 is 6, and 3 would stay the same. And then I would do 6 divided by 3, which would be 2. I could have done the same thing I did before, but I choose to do it this way because then I can show my work and what I'm doing. Okay, so I'm going to keep going. Same thing. Even if it's a double-digit number, it does not matter if it's a double-digit number. I can still do this. My 3 would be my numerator on top. That 12 would then become a numerator. And my 4 would stay the same at the bottom. I would say 3 times 12, which is 36. And then my 4 would stay the same. And then I would do 36 divided by 4, which gives us an answer of... Sorry, I'm trying to... Which gives us an answer of 9. Okay? So pretty much simple, easy. This is just getting us warmed up for the actual lesson today. Second fluency we have is find the unit conversion. So if I have 1 foot, it equals how many inches? For those of us that said 12, you are correct. 1 foot does equal 12 inches. But what if the problem asked us, what is 2/3 foot in inches? And a lot of us would look at a problem like this and be like, oh, I don't know how to do that. That's really weird. So how I would do this is the following. I would say, okay, I know that if I have 2/3 of a foot, right? And I want to break that down first into unit form. That means my number is 2/3 and my unit is 1 foot, right? I can then say, I want to turn those feet into inches, right? And I know that there are 12 inches in 1 foot. So I know that would be 12 inches times 2 over 3. I would just bring this number straight down. So then I can say, wait, I just saw this problem up here at the top. So I can then say 2 times 12 over 3. Oops. Equals 2 times 12 is 24. The 3 stays the same. Well, I cannot have 24 over 3 because that's an improper fraction. So I'm going to do 24 divided by 3, which would give us an answer of 8 inches. Okay, so that's another key way of doing that. Okay, let's move over to our application problem. Before we get started with our application problem, I want to remind everybody that you need to be using cubes. It is super important. I understand we are not in school. I understand Miss Cortez cannot check, but I need you guys to do cubes every single time. This will guarantee you have the right answer. So for our application problems, we always start by reading the problem first before I do anything else. Bridget has $240. She spent 3/5 of her money and saved the rest. How much money did she spend then save? So I'm going to start with cubes and I'm going to circle important information. I know that Bridget has $240. I know she spent 3/5 of her money. I know that she saved the rest. I just want to make sure that I remember that for myself. Okay? There's no more important information, so I'm going to move on to underline. We're going to underline the question. Even though I underlined this, the rest, you can leave it alone. How much money did she spend, then save? Okay? We're going to box in our keyword. In this case, we know we're comparing money and we're comparing the rest. And it also tells me here that we're comparing. Whenever we compare, we are subtracting. We're going to subtract what she spent. We're going to find the difference between what she spent and what she saved. Sorry about that. So, how does that work? We're going to say she has... I'm going to start off by drawing a picture. And so, my tape diagram should have 5 parts because it tells me that there's 5 parts in it. Okay, Papi, I'm coming. I know there's 5 parts to it. I know that 3 of those 5 parts is what she spent. Making the 2 parts right here is what she saved. Okay, so she spent this, spent this, spent this, saved this, and saved this. Okay, we know she started off with $240. Okay, so I'm trying to find, first of all, how much did she spend? Easy enough. I could first start off by saying, okay, I need to figure out what one of those parts are. Once I figure out what one of those boxes are, then I could figure out the rest, right? So first I'm going to start off by saying, okay, $240 divided by 5 should give me that one individual square first, because I know I'm taking $240 and I'm dividing into 5 separate spots. So if I do $240, it would come out to whoop, I'm writing it wrong. $48. So one of those boxes equals $48. All 5 of those boxes equal 240, right? So if I added 48 5 times, I should get 240. So now that I know that, I know 3 of those boxes right there, 3 of those boxes are what she spent. So spent is going to equal 3 times 48. Okay, so that's the first thing we want to find out. So 3 times 48 is $144 is what she spent. Okay, for save, it has to be 2 of those boxes, because here's 1, 2 times 48. 2 times 48 is 96. So she saved $96. So now I know how much she spent, and now I know how much she saved. My question is, how much more money did she spend than saved? This more right here is telling us that we need to find the difference. Again, that means subtraction right here. So I'm going to say, I'm always grab my bigger number, 144 minus 96. I can't do 4 minus 6, so I'm going to go borrow from my neighbor, which I can do. So that 4 turns into 14. That 4 turns into 3. 14 minus 6 is 8. I cannot take 9 away from 3, so I'm going to borrow from my neighbor. 13 minus 9 is 4. So the difference, right? The difference between what she spent and what she saved was $48. So then I'm going to write my sentence. Bridget spent 48 more dollars than she saved. Okay, make sure that when we are working on word problems, we are working them out this way. We are taking our time. Okay, keep moving forward. So now we have our concept development. Concept development is pretty much, I'm going to tell you this flat out. It's so simple. The number here coincides with the number on your problem in which you are working on. So if you open your book and you are on problem set and it says number 1, all those problems under that will be about this right here. Okay? Same thing with number 2. If the number says number 2 and then it says A, B, C, and D, it'll be about number 2 here. So make sure we're using our notes. I will be putting these notes up on Google Classroom for those of you guys who need to use them. Okay, so for number 1, it says write an expression. Expression means problem. Some of us are not using our math terminology. Expression means problem. To match the tape diagram, then evaluate. Evaluate means we're going to solve it. Okay, so I'm going to start off with the first one. If I look at this tape diagram, it is a tape diagram, so it's a hole with 3 of the 4 pieces blocked off. So I know it's going to be 3 over 4, right? I also know that I have a total up here, which I really don't know the total, but I know it's going to be 9 plus 11 because that's what our total is, right? Pretty much it's asking me 3/4 of the sum of 9 11ths, okay? So in this case, I would multiply this because I want to find 3/4 of this sum up here on top, right here. So, why do I see that? Because I see 3/4 and then it's the sum of 9 11ths, okay? And if I was writing that in the words, it'd be 3/4 of the sum of 9 and 11, because that's exactly what it's telling us to do. Now, we've done this before. First, I would do order of operations tells me that I have to do parentheses first. So 9 plus 11 is 20, and I'm going to bring everything else down. Some of us need to start taking our time and writing problems down. Okay? And now I just did this. I did this 2 seconds ago. I would do 3 times 20 on top, and 4 is my denominator. 3 times 20 3 times 20 is 60 over 4, right? 4 can go, then I could do 60 divided by 4, which would be 15. Okay? For those of us who struggle with division, 60 divided by 4. 4 goes into 60 one time. 1 times 4 is 4 minus 6 minus 4 is 2. We're going to bring down our 0. 4 goes into 20 how many times? 5 times. 5 times 4 is 20. 0, so that's where I got that number from. Okay? So moving on to the next one. Same thing. I'm going to look at it. I have a whole tape diagram. I see 5 boxes. 1, 2, 3, 4, 5. So 5 times, okay, and I see a subtraction problem right here. So I'm going to put that in parentheses. 1 over 3 minus 1 over 4. So how I write that down? I write 5 times the difference of 1 over 3 and 1 over 4. Okay? So then I'm going to, again, work it back out. I'm going to first work out on my parentheses. Can I subtract unlike denominators? No, I cannot. I'm going to zoom into that one just so you guys can see what we're doing. I cannot do that. Okay? What I do is I'm going to find a common denominator. I know if I skip count by 4 and by 3, I get to 12. What would I multiply 3 by to get 12? I would multiply it by 4. Whatever I do to the bottom, I have to do to the top. I'm going to multiply 4 by what number to get 12? I would multiply it by 3. So whatever I do to the bottom, I have to do to the top. So now I have a new problem. 4 over 12 minus 3 over 12. I'm going to bring everything down. Now this I can work with. So now I could just subtract straight across. So I'm going to say 4 minus 3 would be 1. And my denominator stays the same. And I'm going to bring everything else down. Here's a problem that we just did. I'm going to do my whole number times my numerator over my denominator. 5 times 1 is 5. And the 12 stays the same. So my answer to this one would be 5 over 12 for the question mark right here. Okay, and this question mark right here would be 15. Okay, any questions as of right now? I hope not. If you have questions at any point, please make sure write them down. Send me a text, send me an email, whatever you need to do to get a hold of me. That way we can talk. The next one, problem 2. It says write and evaluate the expressions from word form. Pretty much we're just translating these word forms into written problems. And so very simple, very easy. The first one says the product of 4 and 2 divided by 3. The product of 4 and 2. Product always means multiply. So I would do 4 times 2 divided by 3. Okay? I could leave it like that. I could also write it as 4 times 2. And I would put 4 times 2 in parentheses because it's the first thing we do. Divided by 3. I can do it either way. It doesn't matter. It's the same thing. I could also write it. Oops. I don't want an equal sign there. I could also write it 4 times 2 over 3 because we just learned that this means the same as this. All these problems right here mean the same thing, okay? Once you find it out, make sure you work it out. I'm going to work it out underneath the first one. Order of operation says multiplication and division from left to right. So 4 times, 4 times 2 would be 8 divided by 3. Which would be 2 over 3 or 8 over 3. Either way, it doesn't matter. It works out. The other one, the next problem we have is 16. 1/6, the sum of 16 and 20. So 1/6, the sum of, so oh, I know what I'm doing. 1/6, sorry, I kind of got distracted a little bit. 1/6 the sum of 6 and so I have 16 plus 20. This doesn't tell you right off the bat that it's a multiplication problem, but it is 1/6 the sum of. This right here means you're going to multiply it by that. So multiplication, okay? Same thing, I'm going to put the sum of. We first have to find that because it says the sum of. The sum of means we do it first. So I would do 16 plus 20, which would be 36 times 1/6. Same thing, I'm going to multiply it. 1 times 36 over 6. 36 over 6, which would give me 6. Okay. Quick little thing. This is the first answer to problem 2 in your problem set. Okay. Next one. Number 3 says evaluate and compare evaluated expressions. They already wrote them down. They just want you to solve them. So order of operations, 2 divided by 3 would be 2/3 times 4, which would be 2 times 4/3, which would be 8/3. Same thing, 4/3 doubled. So 4/3 times 2, which would be 4 times 2/3 equals 8/3. Okay. Same thing here. Do parentheses first. 3 times 4 is 12 divided by 2. 2 divided by 12 would be 2/12. Yes. No? Yes. Yeah, I'm right. Okay. So then I would go on to the next one. Same thing here. 2 times 4/3, which would be 8/3. We're starting to see a pattern. We're starting to see numbers that are the same answer. That's what we're looking for. We're evaluating and comparing the answers. So then 4 copies of the sum of, I put the twice, sorry. The sum of 1/3 and 1/3. So 4 times, because it says copies, the sum of 1/3 plus 1/3. So 4 times 2/3, which would be 4 times 2/3, which would be 8/3. And again, we're getting the same answer. Last one, 2 divided by 3 would be 2/3 times 4. 2 times 4/3, which would be 8/3. Same thing. What we're starting to see a pattern is that you can write the same problem. I'm sorry, not the same problem. You can write multiple problems that use the same numbers in different ways that come up with the same answer. The only one that did not come up with the same answer would be C right here, because that would not work. The way that it is set up, it wouldn't bring it out to be the same answer. But I could write potentially the same problem 1, 2, 3, 4, 5 ways. Okay, make sure we're taking a check at that. Okay. Lastly, you're going to use the skills that we learned today, and we're going to use it to compare expressions in word form and numerical form. So in other words, if they're in word form, they have to be turned into numerical problems and they have to be solved. If they're numerical problems, they have to be solved. Okay, so 1/8 the sum of 6 and 14. 1/8 the sum of 6 plus 14. That 14 looks horrible. Okay, 14. I would first do my parentheses. 6 plus 14 is 20 times 1/8. 1 times 20/8, which would be 20/8. Okay, I'm going to leave it in improper fraction. It doesn't really matter right now. 6 plus 14, so I'm going to leave that one. Here's my answer to this side of the problem. So this is for this side of the problem. 6 plus 14 is 20. divided by 8, which would be 20 divided by 8, right? So in this case, this problem would be equal, okay? The next one, 4 times 8 over 3. 4 times 8 is 32 over 3. Again, I'm going to leave it in improper fractions. It really doesn't matter right now. 4 times, so 4 times the quotient. Quotient means division problem. So 3 divided by 8, okay? 4 times 3 over 8. 4 times 3 over 8, which would be 12 over 8. So, I need to find a common denominator for these fractions to be able to work them out. I'm just double checking, making sure I'm not giving you guys the wrong thing. Okay, so I would have to find a common denominator. I would multiply this by 3, which would give me 36 over 24. Sorry, I'm going to the next problem. Now I'll multiply this by 8. So 32 times 8, 256 over 24. So this right here is a bigger number. So our answer would be greater than, okay? Make sure, remember, we have to find a common denominator whenever we're comparing fractions. Lastly, subtract 2 from 1/2 of 9, okay? So 1/2, subtract 2. Oops, I'm writing it wrong. I'm doing it backwards. I'm sorry. So 1/2 times 9 minus 2, okay? That's what we're doing for that one. Did I forget to write the other problem? Yeah, but I forgot the other number for this one. Minus 2. Sorry, I forgot that part right there. So I would do, first I would work on the 1/2 times 9, which would equal 9 over 2 minus 2. Okay. I'm going to turn that 9 over 1/2 into a whole number. So 2 goes into 9 4 times with 1/2 minus 2, which the answer for this would be 2 1/2, which we've already done all this, guys. So it should not be difficult. This is just turning this improper fraction into a mixed number and then just subtracting. We know how to do that. So our answer for this one would be 2 1/2. This one would be 11 over 2 minus 2. Same thing, we're going to turn this into a mixed number right here. 2 goes into 11 5 times with 1 left over, minus 2, which would be 3 1/2, which it would be less than. Okay, so again, this is pretty much the gist of it. You guys have an exit ticket that will be on Edulastic. Make sure you do your workbook pages so that you guys get practice. I will be sending these notes so that you guys have them. And if you have any questions, please reach out. I am available. It might take me a couple minutes to reach out to you guys, but I am here for you guys for whatever questions you guys have, whether it be not understanding what's going on in math or just needing to ask a quick question about how to log into something, okay? So please reach out. I hope you guys are safe. I hope you guys are healthy, and I hope to see you guys really, really soon. I'll talk to you guys.